In this first example, we're just going to come in and create an electrode around this single letter of a logo. Go straight into our solid core, just do a straightforward solid core capture of this. But upon reflection, I can see I could probably get all these letters in. So what I can do now is just hold down the Shift key, and just add these extra letters now to this electrode. And then what we'll see is the solid core area automatically updates to include these new additional letters for this electrode. I can now come in, just do a manual alteration here, just increase the height slightly. When I select OK, what we'll see now is that whole electrode core area has been captured. I'm just going to apply some clearances to this. So I'm just going to come in now and just use some straightforward measuring tools. Just measure between these 2 points here. I can see the distance is 3.13 millimeters. So now I can just come into this electrode, just select the individual faces I require, and what I'm going to do now is just do an offset here, minus 2.7 millimeters to the bottom face. We'll see a blue outline, which is telling us where the area will be. I can tick and accept that. This solid core now has been offset. I can turn this back into an isometric view. I can go and turn that now into my first electrode. So just make my mold tool active, select the solid core, then just go through the electrode wizard. I'll first of all apply a base. Now what I'll do here, I'll come from a standard 3R blank, but we can also see now we have a frame automatically applied to this electrode. We can choose a Z value here, which should set then for a value that we would require. Or I can rotate this blank around. Even at this early stage, I can extract away that electrode, have a look at the face underneath, tick OK, and go now to my next screen. I can choose an appropriate holder. In this instance, I'm going to use an Aroa holder. I can get a picture reference of what that looks like from the catalogue, or I can go back to the text description of this. I can also rotate this holder around if I so wish to put it into a more suitable orientation. But notice as we do this, this automatically updates so we can move around in the screen. I can now set the counter for my first electrode, and I can select which style of sheets I would like to create. In this instance, it's just going to be a general assembly sheet. I'm going to create that on level 30. I can now go from a selection of undersizes, so from AGI, Zimmercrime or OPS. In this instance, I'm going to use OPS. I can use my user-defined spark gap, go to a minimum spark gaps required for this electrode, or I can use the maximum. All this from the default settings by the OEM. In this instance, I'm not going to export anything at all. And I'm just going to click here, finish at this stage, and create my next electrode. We can see the general assembly here. This is the customised general assembly. We can see the view shades in the bottom right hand corner. A customer logo can be applied in here. And again, with the position of this electrode on the mould tool. The next electrode I'm going to create now is going to be for this rib area on this tool. I'm going to select that rib. I'm going to come in now. I'm just going to do a lasso selection all the way around. So I'll get the rib, plus I'll get those top radiuses that are included here in this rib area. I'll do the solid core capture. Apply an offset on here of 2 millimeters. Again, I'm just going to apply now just a manual height on this, just give it a bit of depth. Having done that, we can see then we've also got these pins that have been caught in this capture, as well as the base of the mold tool. We can remove this now very easily using our direct modelling tools. So in this instance, I'm just going to come in, select just this one face here, then just split that face on this electrode. Having done that, I can just delete that away. I can now come in to remove the unnecessary areas from this electrode capture. Having done that, I can come in here, just do that lasso select. I'm just going to do a remove and heal now, and all that's been removed. Again, I can do it for this area in here. I'm just going to move these radiuses away, automatically remove and heal. Now I'm going to do it just the face selection for the first side. And of course, I would have one radius left on the far side. Just select that, and again, just remove and heal. Select these individual faces here, the pins, so I don't require these in my electrode. So with the shift key down here, I can just add all the additional faces that I require. Just do the remove and heal. We can see now that it has indeed done that, but we get these two cavity errors at the top. So what we're going to do now is come into concave selection, select the first and then the second. With the remove and heal, all the adjacent faces have been re-intersected to heal that area. What I haven't got yet is an offset area for this whole bottom face. So what I'm going to do now is come in just for individual face selection, select those, go into my editing tools here, into my general edits, and apply an offset on here of 2 mm. We see the blue outline giving us indication of where it's going to go. I'm going to choose the next selection just to remove here that extra area. I am happy with that. I can accept this. I'll come back in and have a look at my mold tool. So that ribbon's been done. What I'm going to do is I look further up. I can look at my other ribs and I can see that one's different. So before I create that electrode of that core capture, I'm now going to come in and just create another core capture around that area. This time we'll do a concave selection, just inside that area. Go to the solid core capture. What I'm going to do now is just do that capture again. Use the same settings here. I'm just going to do a 2 mm expansion. I'm just going to come in and have a look. Just apply a little bit of depth on here. Select that area. What I'm going to do this time, I'm now going to use the multiple face split. So I'm going to select the first face, the second and the third. And again, using exactly the same functionality as before, the split face, we'll now see that all those faces have been removed in one operation. Select this face here, just do the remove and heal, and extend straight out. We'll have a look around now, see how this is on the mold tool, and compare it to my electrode created previously. I can see here that there's a bit of a height difference, and I would like those to be the same. So I'm just going to come in on this electrode that's going to be created from this core capture. I'm just going to select that top face, do replace and face now with the face on this core capture, do apply, and now in our view from the side they'll both be at the same height. I'm just going to come now, just remove that second electrode. I'm just going to turn this core capture now into an electrode. So with the mold tool active, select this core capture, go into the electrode wizard. Now in this instance I'm going to use a user defined base. Increase the width here to 40 mm. Just increase the height slightly to 30 mm. Let's change the length here to 10 mm. You can come across. I'm going to choose now a suitable holder. Again, I'm going to use an arrow on here. The count has automatically changed, and as so has the level. I'm going to go in, change it to an OPS undersized dataset. Go to my next screen here and finish that. That's my second electrode here created for me. We'll see now that the general assembly sheet has been updated to include this electrode. On this view. I can come back now and create my third electrode. turn this off. We're going to go in, select in from this cross area here. So on this solid, I'm just going to go in, it's going to partial selection here of just this area. Come into the solid core capture. Now, just by clicking here, I'm going to change this to a round shape. So I'm going to do this from a round piece of bar. Just give some height on here. Let's go OK. What we'll see now is that we've captured this core. We've gone inside here, and that's more than we would wish to do. So what I'm going to do is just split now this solid core capture. So I'm going to select a point here, click Apply. And what we'll see now is its whole area has been split from the main solid. I'll just delete that away. And again, I can select these fillet radiuses here just by coming into this solid core capture by a lasso selection, remove and heal. Now select this face and just remove it all the way through to the base. See the outline of where it's going to go. Tick OK. We can remove that. And now when I turn the mold tool back on, we can turn that core capture then into an electrode. So if we come to our main tool itself, again just make it active. Select the solid core, come into the wizard, now apply a suitable blank size to create this electrode. So you get a better view. Again, a frame has been applied to this automatically. Select a 3R holder. Extract this electrode away so the form's going to be. Turn that down. There's my next screen. This time we're going to change the setup sheets that are going to be required. I'm going to create a detail and a custom setup sheet here, as well as it being applied to general assembly sheet. I can use here my OPS spark gaps, or I can come in and use user defined. So that's based on the similar areas that have been used previously using this electrode material. Go to my next screen. Now I'm going to export this now for PowerMill. What I'm going to do is create now a script file to use on my spark erosion machine. We have common spark eroders here. So from AGI all the way down here to the Zimmercrane, Mitsubishi's. This instance I've used OPS information, so I'm going to use an OPS script file. I'm going to create some inspection points now on this electrode. So I can change the probe radius to suit the size of the electrode. This instance it's correct at 1.5 millimeters. Now first of all, I'm just going to apply here some inspection points which I'll use later in Power Inspect to check the position of the electrode. Now I'm just going to come in and just create inspection points to check in Power Inspect. When I've done that, I can click for exceptions. But when I click Finish now, all this information is going to be written out into a single trode file. So I'll have the detailed setup sheets, the general assemblies, the 3 electrodes. The script file will be created for me for my OPS Ingersoll control, and all this will be outputted into this directory, so I can then come and view it and send it directly into my EDM control, minimizing any error that can be done with the human input by using the automatic script file creation. I'll select No, go into each of my individual sheets. Again, we can put customer logos, customer details. All this is fully customizable within PowerShape. The positional information for the electrodes is shown. I can come back to my mold tool. Now in this instance here, if I was just turn on one electrode, I can come in, just go on to burn area shading. I can then come in and do a simulation of this electrode and recognise all the burn areas. I can move this away, and in so doing, what we can see then, we can see the red areas of the burn, the yellow before it becomes starting to become clear, and green for the material block itself. We can now look at the script file that's been produced here for this OPS control. Go into my notepad. We can see now that for each of these individual electrodes, we have the undersizes, the name of the electrode, plus of course the depth, the areas and the material, as well as the surface finish required on that electrode. This together with the positional information. The single trove file has been created for us, which we can now go and use in PowerMill and in Power Inspect. We are now going to extract an electrode from the trode file that we just created in PowerShape. We have the names of the electrodes there, together with a screen capture of the electrode itself. We're now going to give the electrode appropriate name. We can create the material block automatically from information that was defined in PowerShape. We can then come in, have a look and analyse this visually, interactively and very quickly. You can soon see there's a radius in there of around 0.3 millimeters. So I can see it's 0.2 millimeters there. I can engage with all the measuring functionality of PowerMill at this stage. Have a look at the draft angle. I can see on this electrode it's 1.5 degrees or less. I can import any additional tooling here, so the tooling templates that were saved, these can be the carousel of the machine, or these could be the kind of parts we use, or per customer. In this instance I don't wish any additional tooling, so I can just click next to go through. From predefined toolpath templates that we have created, we have an image that's stored with these to give us representation of the kind of work they're used for. We also have the spark gaps automatically loaded into this undersize area. What we'll see then in PowerMill, this information has been imported, is that the toolpaths have come in into individual folders. The folders are named the same as the electrode, with a description of how they're going to be used, together with the undersize information. The templates are brought into each folder. However, each template will have these undersizes automatically applied. So in this instance we can see on this toolpath a 0.2 millimeters negative thickness. The 0.2 millimeters undersize in this folder has been applied automatically for us. By going through to my next screen now, when I click finish, what we'll see now is that all these toolpaths will be calculated for us automatically. So for the model area clearance, flat finish, an automatic steep and shallow toolpath, a corner finish to pick out these tight corners in here, together with a frame. Now frame toolpaths begin with the word frame, so when the processing is done, the system then knows not to apply any thicknesses to this region when it is machined. Now we'll see, using the PowerMill functionality, these toolpaths have automatically verified as they go along, giving us that green tick so we can ensure that these toolpaths are indeed safe and ready to run. What we've seen up here now, we've seen the plus has been applied to this NC programs, because as each of these programs are calculated, they're also added to the NC program of that whole folder. So as this calculation is done for the first electrode here, we can go along and have a look at Power Inspect and how that uses the trode file. Using the CNC Electrode, we're now going to extract from the trode file the SPM3 electrode here. This has been imported to us into Power Inspect using the electrode blank sizes and the undersize information. Then move the probe away from this electrode. We'll zoom in, select our finisher points. So we'll get the frame and point information that's on the electrode, together with the undersize information. We can then come over and run all these points through. We can see the probe paths automatically calculated for us, and on the frame as well as the impression. We can now go through we can do additional inspection requirements if we so wish. If not, we can go straight through now and have a look at the results of this electrode for us. These will be presented to us in our inspection report. All the customised information can be included in the top here. The full power inspect functionality is available. Linear deviations, all shown to be within tolerance and perfectly acceptable. When we click next now and finish, all this information is then written out back into the Trode file. We can now go back into PowerMill and have a look at our calculated toolpaths. We'll see here in PowerMill all these toolpaths have been calculated for us. So for the model area clearance, the flat finishing toolpath to come to the bottom of this electrode, the automatic steep and shallow, the corner finishing in here, together with the frame itself. These are then applied to the NC programs, where we can write this information out. We can have a look at the NC program data that's being produced in Notepad and see all the code is produced. So what we have seen now is that we've created the automatic script files in PowerShape, we've automatically created here the NC programs to run on the machine tool, we've created the probe path inspection reports in Power Inspect, all done using the new Delcam Electrode solution.